The Dragon cargo ship that is launching today is carrying a variety of supplies for the station and its crew members, including several new experiments, some of which are designed to learn more about how plants grow in weightlessness. One of them is known by the acronym CARA, C-A-R-A, and the principal investigator, Dr. Annalisa Paul of the University of Florida, is on the phone with me this morning to talk about that. So it's an exciting day today because we've got this cargo craft that's going up, and we know we've got several lots of supplies and several experiments. One of those experiments I wanted to talk to you about is CARA. We said this is an acronym. Can you tell us what CARA stands for and generally what you are trying to find out in this investigation?
Sure. So CARA stands for Characterizing Arabidopsis Root Attractions, and it is flying a type of plant called Arabidopsis thaliana, which is essentially it's a model organism for plants. It's what you might think of as the white mouse of the plant world, and it is utilized in a lot of different ground studies, as well as we've run a number of different spaceflight experiments with Arabidopsis in the past. What we're trying to find out with this particular experiment is some of the nuances that plants use to sense their environment as they grow without the cues that you normally have in place. And so on the ground, of course, you've got gravity, which roots grow towards gravity, and shoots, the leaf part, grows away from gravity. And the other major cue for growing on the ground is, of course, light. And so what we're trying to do with this particular experiment is we are taking gravity out of the equation and looking how plants grow on the surface of these square auger plates when the light source isn't a directed one, as opposed to coming just from one direction, and seeing how the roots and shoots grow in that very diffuse lighting environment of just slapped up against the bulkhead of the space station with no gravity also to give them direction.
So tell me also, we were just looking at a couple of pictures of these plants. What kind of plants are you flying, and then why did you pick them for this particular experiment?
So as I said, these are Arabidopsis thaliana. That's the genus and the species of these plants. We usually just call them Arabidopsis for short. We chose those because, as I said, they are the model organism for plants. We know everything about their genome. It's been completely sequenced. It's very well characterized on in ground experiments. It's been used for just decades and decades in plant physiology, plant molecular biology research. In addition, Rob Furl and I, my colleague in this business, have done a number of different spaceflight experiments with this same plant. And so every time we do an experiment, we get answers, and those answers then develop into new hypotheses and new questions. And so the experiment that we're launching today with these plants is actually based on information that we got from a previous spaceflight experiment with these same type of plants.
Tell me, how will the station crew members be actually participating in the experiment? What will they be doing with the plants?
Well, in two ways. One is that part of what we would like to do is we're looking at the molecular biology of these plants, and so not just how the roots grow, but what governs the way they grow. And part of the mechanism to do this is we've engineered these plants with something called the green fluorescent protein reporter gene that is essentially reports back to where certain genes are being engaged as the plant grows and develops. It glows green. But you have to have a special mechanism to see the fluorescence. You can't just see it in regular light. And so one of the things that we can do is use a device called the LMM for light microscopy module that's on station. It's essentially a very sophisticated fluorescent microscope that is run by a Glenn Research Center. And so what the astronaut will do is they'll take one of the plates, and there's a number of plates that are being flown, but they'll take one of the specific plates that has some of these engineered plants on it and put it on the light microscopy module apparatus. And then what we will do is we'll be traveling to Glenn Research Center to then use the microscope up there to manipulate what's on station. And so the astronaut will put the plate on the microscope, but then it will be managed by some of the engineers and scientists at Glenn Research Center as we see what is glowing on orbit.
Thank you so much for talking with me today, Dr. Paul.
Oh, you're welcome.